Welcome to differentiation of inverse functions. So we've looked at inverse functions before. So we know that for some function f of x, the inverse is f of minus 1 of x. But we're going to let that be equal to g of x, so an alternate function. One of the properties of an inverse that we learnt was that if you take the inverse of the original function or the function of the inverse, it equals to x. So if we were to differentiate both sides, so that is differentiating g f of x and differentiating x, we'd get g dash of f of x times f dash of x. So that's part of the advanced course. And then for f dash of x would equal to 1 over g dash of f of x. Now this is going to be something important that we will use. So let's have a look at how it plays out, just for an example, like f of x equals ln x. So if we're going to let g of x be the inverse, then we switch the x's and the y's, so x equals ln y, make y the subjects, so y equals e to the x, which means g of x equals e to the x. So that's the inverse of ln. So the derivative of ln x is 1 over x, and the derivative of e to the x is e to the x, f dash of x and g dash of x. So using our rule, f dash of x is equal to 1 over g dash of f of x. So f dash of x was 1 over x, and we get g dash of f of x is e to the ln x, because f of x was ln x. So you get 1 over x equals 1 over x. So that's using an example to show that f dash of x equals 1 over g dash of f of x. So here's an example from past HSC, so the 2023. F of x equals 2x plus ln x, and explain firstly why f of x is a function, and then we're going to considering f of 1, we're going to show or evaluate g dash of 2. So firstly, to be a function, so we can either prove that through a graph that it meets the horizontal test, or we can find the derivative and prove that it's either always, well in this case increasing, because we want it to be greater than 0. So 2 plus 1 over x is greater than 0 for x greater than 0. So since the function is always increasing, therefore it's a 1-to-1, and therefore the function has an inverse. So that's why we end up with we can end up with an inverse. So the second one, g of x. So firstly, f of 1 is equal to 2. So if I sub 1 into 2x plus ln x, g of 2 is equal to 1. So remember, the x and y for the function can flip for the inverse. So if f of 1 is equal to 2, then g of 2 is equal to 1. So we don't even have to go and find the actual inverse. G dash of x equals 1 over f dash of g of x. So g dash of 2 is what we're trying to find. So that's 1 over f dash of g of 2, which is f dash of 1, because we've just shown that g of 2 is 1. And we found f dash, or we can find f dash, that's 2 plus 1 over x. So when I sub 1 in, we get 3, and so g dash of 2 is equal to 1/3. So here's a polynomial that passes through the point 1, 3. Find the gradient of the tangent to the function x g minus 1 of x at the point where x equals 3. Now hopefully straight away you recognize that gradient of a tangent means we've got to differentiate x g minus 1 of x, so that's x times the inverse, means it's a product rule. So let's have a look at how we do this one. So if g of 1 is equal to 3, then g minus 1 of 3 is equal to 1. So we're going to use the product rule to find f dash of x. So f dash of x is g of minus 1 of x times the derivative. So this is the product rule of the x. And then you add the x times the derivative of g of minus 1 of x. So let's focus on that, just the derivative. So if y equals g minus 1 of x, then x equals g of y. So that means dx to y is equal to g dash of y. And dy dx is the flip of that, is 1 over g dash of y, where y was equal to g of minus 1. So the derivative part of g of minus 1x is 1 over g dash of g of minus 1 of x. So that's the derivative. So therefore f dash of x is going to be equal to g of minus 1 of x plus x times 1 over g dash of g minus 1 of x. So if we want f dash of 3, that means we replace the x's with 3's. G of x was equal to x cubed plus 4x, so g dash of x is 3x squared plus 4. G dash of 1 is 7. So replacing that in our formula, we're going to get 1 plus 3 lots of a seventh. So f dash of 3 is equal to 10 over 7. So the gradient of the tangent is 10 over 7. Thank you.